Hello friends, how are you? So today I'm gonna solve this problem crawler log folder. So basically what is happening, there are three commands we are given and these commands are related to folders movement, right? So let me explain in a simple way with a diagram. So suppose we have in our computer, right, lot of folders are there. So suppose we have a folder, this one is a parent folder, let's say. Now inside this parent folder we can have another child folder, right? And inside that child folder also we can have another folder, right? Or similar way there could be multiple folders. Okay, now we have three commands which are basically related to the movement of the cursor to these folders. Okay, so let me explain what those commands is. So see here, I have made one parent folder. I have given a name parent for it, and inside the parent folder we have a folder called C1, child one you can call it, and inside C1 also we have another folder called C2. Okay, now we will talk about these are the three commands: dot dot slash, single dot slash, and x slash. So first one, dot dot slash. So wherever we are calling the first command dot dot slash, it basically bring back us to parent of it. Okay, so for example, let's say I am here, I am at here inside the parent only. So if I call this guy dot dot x, it will not go because parent is the only parent guy here. It doesn't have any parent, so it will stay there. But in the case if this x was here in the next, for example, if my x was here inside C1, okay, and then if I call this first command, then this x would be moved to its parent. Okay, so this guy would be come back to its parent. So this would be something like it would come back here similarly. So basically it will bring back to the parent of it, and if it is already in the parent itself, then it would be stay there. Okay, so that is first command. Now we'll talk about second command. So second command doesn't do anything. Wherever we are calling it, it keep it stay there only. Let's say my x is right now here, it will keep it as it is. If let's say I am just removing this x and I am, let's say, writing it here. If this x was here and if I am calling this second command, it doesn't do anything. The x would be keep as it is. Okay, so this is about the second command. Now we will talk about third command. So in third command, what happening, this x is basically the folder name. Okay, so folder name slash, if we press this, then it will move it to the folder which is given. So for example, we are here, let's say x is here in the parent folder, and if we call this function like C1, okay, C1 slash, okay, so this guy would be moved to C1, right? So inside C1, so this x will move to here inside C1 because we have called that folder name. Okay, C1 slash, so that is why this x would be moved to here. So basically this is folder name, and it will move from parent to this child, whatever name. X could be any name which is the child of the current folder. Okay, so these are the three commands. Now what the question is, in the question we are given a folder called log folder, okay, which has all these commands. Okay, that what all commands were made here. So there could be like movement according to those commands, right? So we have to find that how many steps would be required to bring back the movement to the original parent, means the first folder, parent folder. Okay, let me show you. So see here, we are given a log folder. So these are the command movements. So according to these commands, there would be the movement of the values. Now whatever would be the final state, from there we have to find that how many movements are required to bring it back to the main folder. Okay, so let's take this example. Let me take this example. Okay, so see here, I just gave D1 and D2 name and parent folder. So see here, D1 slash, so third command is called here D1 slash. That means from initially we were at main, and from main after this command called D1 slash, so this guy would be moved to, let's say we are calling it x, then x will move to D1. Okay, so now x is inside D1. Again they call D2. So our X would be moved to D2. Okay. So let me remove these things. These guys are of no use. Now see what is the next command. Next command is double dot, the first one. What does first one do? First one do bring back the guys to the its immediate parent. Okay. So when third command is called, X will move back to the parent of D2, which is D1. So what it will happen? This guy would be moved to previous condition. So it will come again, came back here. So we are done till here. Now they are calling D21. Okay. So D21 could be another folder. Let's say inside this guy. So right now we are inside D1. So D1 could have another folder called D21, right? So D21. So when we are calling this command D21 slash, then X will be moved to this guy D21. Okay. So X would be moving to D21. So let me do that. Okay. So now new location for X would be this guy. Now it is here. Now finally this slash, okay, dot slash. So dot slash doesn't do anything, right? Now our question is, we are finally inside D21. Okay. Now the answer is that how many steps would be required to bring it back to the parent folder. Okay. So what is the command which bring back to one folder? First one, right? Double dot slash. So if we call double dot slash here, it will bring it to here, right? So one option happened. Okay. Now we are inside the D1, but we need to come to parent folder. So if we again call same command double dot, we will be come back to here. So X initially, X was after doing these log files, it was inside D21. Then we called the first command double slash, that double dot slash, then it bring back to D2 or D1. Then we again call the same command. So then it will bring to parent folder. So 1 plus 1. So there are total 2 operations required to bring it back to the original folder, the parent folder. Okay. So this is what we have to do, and the approach would be simple. What we will do, we will implement the parent, we will represent by 0, and whenever any movement is happening by the command, third command, then we would be increasing it by 1. So let's say 0, then this command D1 came back, right? D1 slash, then we are making 0 plus 1, so it would be 1 here. Okay, then it is calling dot slash, right? So dot slash means we will do minus 1 of it, because it bring back to parent folder. So 1 minus 1, it is 0 again. Then we have this thing D21. Then it would be D21 will be again increased by 1. Okay, so the value would be 1 here. Okay, then we have this guy dot slash. So it wouldn't do any difference, right? So from 1, how many we have to call 2 times first command. So when we call back this here, okay, then we have to commit back here, right? So this would be what we have to do. So initially it was 1, then it would be increased by 2. When we will count first command, it would be 2 minus 1, so it would be 1 here. Then one more time we will count first command, then it will bring us to the 0. So basically we will just initialize X equal to 0 and keep on increasing or decreasing according to these command. So let me show you my code. So see here, what I have just declared int X equal to 0, means this is inside a parent. Okay, now we are traversing through log, and I'm taking the command into this variable, temp variable. Okay, I just removing the last one, which is slash always. So then I'm checking if it is double slash, that means it is the command which moves. So if we are greater than 0, then we have to decrease by 1, right? First command. Or if it is already 0, that means it is already in the parent, so we cannot move it further. Okay, so this is for the very first command. Then we have if it is not equal to single dot, that means we are here to call the folder movement. Okay, so folder movement we increase by 1, so I am doing X plus plus. Otherwise that would be single dot. So single dot we don't do anything, right? So in this way finally we would have the X value. So whatever the value of X, that many distance, that many operations would be required to bring it back to the parent folder. So we don't have to do anything, only X would be accommodated. So let me execute this code. Yeah, so I am running this code and it is running fine. Let me submit it. Yeah, so it is working fine. Or why it is showing, it was showing 99%, or suddenly it is reduced for some reason. Anyway, that is the O of n, it is 99.42%. So we are doing in linear time complexity. So thank you for watching the video. If you have any concern, please make a comment over there.